Hello everybody, welcome into another lesson. So today we are going to continue on with Cramer's rule, but we're going to do it for a three variable system of equations. So here you have, of course, your three variable system of equations with three different equations that'll have various x, y, and z coefficients for those variables. And then to the right of the equal sign, those are what each of the equations are equal to. Well, we can use Cramer's rule for a 3 by 3 system also. Heck, you can use it for a 10 by 10 or whatever you have. I wouldn't recommend doing that. I'd probably recommend using a graphing calculator at that point, but for a 3 by 3 we can still relatively easily do that by the Cramer's rule. Of course, what you got to do, like for a 2 by 2, you'll get your D determinant, which is simply the determinant of the coefficients on your variables. So you have three equations, you'll have three rows. So you'll take your x, y, and z coefficients of the first equation for your first row, x, y, and z coefficients for the second equation for your second row, and then your x, y, and z coefficients for the third equation for the third row. Once you found your D, what you need to do next is find your D sub x, which, much like the 2 by 2s, you're going to take all the x coefficients in that column, replace them with the values to the right of the equal signs. So you're going to substitute, in this case, a, b, and c in for your x coefficients, and then you'll keep your y and z coefficients the same. Once you found D sub x, you could find x simply by taking D sub x and dividing it by D. Once you found that, then we can find D sub y, which, when you go for D sub y, you'll take the determinant of, this time you'll leave your x coefficients alone, you'll keep the x coefficients, but your y coefficients you're going to replace with a, b, and c, which is to the right of the equal sign. Then you'll keep your z coefficients the same. Then to find y, once you're done with that, you'll take the D sub y and divide it by D. Again, remember, whatever variable you're trying to solve for, that's the column of variable coefficients you want to substitute for what's to the right of the equal sign, if that helps you. And then, of course, we find D sub z, where you leave your x and y coefficients alone, but you take all your z coefficients, replace those with a, b, and c, whatever the equations are equal to. And it'll be the determinant of that. And then, of course, z is going to be equal to d sub z over d. Then once you know x, y, and z, you can list this as an order triple, which would solve the system. So I have about 3 examples here, but they are kind of long, so that's why I'm only doing 3. But you'll get to see exactly how this works for a 3 variable system of equations. So let's see here. First one, we have x plus 2y minus 3z is going to be equal to negative 2. Then we have x minus y plus z is going to be equal to negative 1. Then we have 3x plus 4y minus 4z is equal to 4. Alright, so we have x plus 2y minus 3z equals negative 2, x minus y plus z equals negative 1, and then 3x plus 4y minus 4z equals 2. So we're first going to find the D determinant, which is a 3 by 3, and as you know, a 3 by 3 determinant is quite a bit of work. So once we find that value, I'm going to write the value up here, then I'm going to erase all the work, then we'll go for D sub x. There will be quite a bit of erasing with this, because I would run out of room on the board otherwise. But let's take our D determinant first, the coefficient determinant. So for that, I'm just simply going to take all my x coefficients first, the 1, and then the 3, then take my y coefficients, which would be 2, -1, and then 4, and then I'll take my z coefficients, the -3, the 1, and the -4. Alright, so there is my coefficient determinant. Oh, one more thing I should probably go ahead and add. I should add my coefficient matrix, my coefficient determinant up here, just so we have a little cheat sheet, so to say, for what signs we're going to use. It's always good to set yourself up with one of these, so you know whether to keep what you have positive or negate it. So now that we have all that set, we're good to go. And if we look at the second row, we have all ones. So I'm going to say we work with the second row. So let's look at the first entry of the second row. The first coefficient's a +1, but according to my coefficient matrix, I need to negate that +1. So it's going to be negative of whatever determinant's left over, because I have to strike out both the column and the row in which that occurs, giving me a remaining 2x2 determinant of 2, -3, 4, and -4. Alright. So now let's rebuild this a bit here. And see, -1, 1. Alright. Next then, for the second entry in the second row, we have a -1 coefficient, and according to my sign matrix, I'll keep positive of -1, so that'll be minus another determinant. Then again, strike out the column and row in which it occurs. This time we're taking out the second column and the second row. So the resulting determinant is going to be 1, -3, 3, -4. And then we should have one more determinant to work with. So let's rebuild this again. 1, all right, the y's, let's see, 2, -1, 4, -3, +1. All right. And then for the final entry of the second row, we have a +1 coefficient, but according to my sign matrix, I need to negate that. So it'll be minus yet another 2x2 determinant. So this time we're going to strike out the third column and the second row for where it occurs. So the resulting determinant is going to be 1, 2, 3, 4. Alright, so now we have our 3 2x2 determinants that result from this. So take negative of the first determinant. 2 times -4 turns into -8. Minus -3 is +3 times 4. That'd be +12. Alright, so then we'll do minus the second determinant. 1 times -4 is -4. Now -3 is +3 times 3. That'd be +9. Alright, and then we have minus the final determinant. 1 times 4, that's going to be 4. Minus 2 times 3, that'd be -6. So let's simplify this a bit more. Negative of the first set of parentheses, -8 plus 12 is +4. Minus your second set of parentheses, -4 plus 9 is 5. And then we have minus your third set of parentheses, 4 minus 6 is -2. So this is going to turn into -4 minus 5 plus 2, which would end up giving us -7 for the value of D. So D has a value of -7. So now we have found the value of our coefficient determinant. Now we can go on to solve for D sub x, D sub y, and D sub z, which will give us the value of the variables x, y, and z. Alright, so let's figure out D sub x. So set up your determinant. Now this time, since we're solving for d sub x, you're going to take all your x coefficients, replace those with a -2, -1, and then 4, but keep your y and z coefficients the same. So 2, -1, 4, and then -3, 1, and -4. Alright, well, I still like the second row because we have a lot of 1s here. We have all 1s in the second row. So my first coefficient this time in the second row is -1, but according to my sign matrix, I need to negate that -1, so it'll be positive. So it'll be the positive determinant of whatever's left over once I strike out the first column in the second row. So the resulting determinant is going to be 2, -3, 4, -4. Alright, so there's the first determinant. Now I'm going to rebuild this. Alright, so the second entry in the second row is -1. According to my coefficient matrix, I need to do positive -1, so that would be minus the resulting determinant of when I strike out the second column in the second row. So there's my resulting determinant of -2, -3, 4, and -4. Alright, let's rebuild this one more time here. -1, okay, so then 2, -1, 4, -3, 1. Okay, there we go. And then the last entry in the second row is a +1, but according to my coefficient matrix, I need to negate that +1. So it'll be minus the resulting determinant of whatever's left when I strike out the third column in the second row. So my determinant ends up being -2, 2, 4, and 4. Alright, so now we got all of our 2x2 determinants. So first determinant, 2 times -4 is -8, minus -3 turns into +3 times 4, that'd be +12. Alright, make sure everyone can see stuff. Very good. Minus the second determinant, -2 times -4 is +8. Minus -3 turns into +3 times 4, that'd be +12. Then you have minus your final determinant, -2 times 4 is -8. Minus 2 times 4, that'd be minus another 8. So let's see, first parentheses, -8 plus 12, that's going to end up being 4. Minus your second parentheses, 8 plus 12, well, that's going to end up being 20. Minus your third parentheses, -8 minus 8 is -16. So this will turn into 4 minus 20 plus 16, which would end up giving you 0. So d sub x is 0. Now, to find x, you'll take your d sub x and divide that by your d. D sub x was a value of 0. Divide that by -7 for your d, and then you just get an x value of 0. So x is 0. I'm going to write that up here. We got x to be 0. Now let's solve for d sub y and ultimately y. Alright, so d sub y. This time for d sub y, we're going to set up another determinant. This time we leave the x coefficients alone, so it'll be 1, 1, and 3. But your y coefficients you'll replace with that -2, -1, and 4. Then you'll leave your z coefficients alone, the -3, the 1, and the 4. -4, excuse me. -3, 1, and -4. Okay. So there's our d sub y determinant. So I'm going to work with the second row again because we have all 1's in there. So the first entry in my second row is a +1, but according to my coefficient matrix, I need to negate that +1. So it'll be negative of whatever the resulting determinant is when I strike out the first column and the second row. So my determinant would end up being -2, -3, and then 4, -4. Alright, so there's that, and I'll rebuild this and we'll figure out the next determinant. Alright, x we left alone, 1, 1, and 3, and then let's see, -2, -1, -3, 1. Okay, there we go. Alright, second entry in the second row is a -1, and according to my coefficient matrix, I need to do positive -1, so that'll be minus another determinant. So it's going to be resulting from the determinant of when I strike out the second column in the second row. So the resulting determinant is going to be 1, -3, 3, -4. Alright, then we got one more to figure out. So 1, 1, alright. -2, -1, 4, -3, +1, -4. Alright, there we go. Then the final entry in the second row was a +1, but according to my coefficient matrix, I need to negate that. So it'll be minus whatever the resulting determinant is when I strike out the third column in the second row. Okay, so my resulting determinant would be 1, -2, 3, and 4. So now let's solve all these determinants. So take negative of your first one. So -2 times -4 turns into +8. -3 is +3 times 4. That'd be +12. Alright, then minus your second determinant. 1 times -4 is -4. Minus -3 is +3 times 3. That'd be +9. Minus your third determinant. 1 times 4 is 4. Minus 2 is +2 times 3. That'd be +6. Okay, so let's simplify. Minus your first set of parentheses. 8 plus 12 is 20. Minus your second set of parentheses. -4 plus 9 is 5. Minus your third set of parentheses. 4 plus 6 is going to be 10. So this turns into -20 minus 5 minus 10, which would end up giving you -35. So d sub y is -35. Now to find y, you're going to take your d sub y over your d, which d sub y was -35, and then d was -7, which -35 divided by -7 is +5. So your y value ends up being +5. So now we know x and y, we can go for d sub z and solve for z, which will then give us the order triple. That's the solution to this system. And if you need to see the previous work I've done, feel free to rewind the video as much as you need to. There's no shame in that if you need to. I just don't have the room to write all of this up here at once. But d sub z, set up your determinant. This time leave both your x and y coefficients alone. So for x I had 1, 1, and 3. For y I had 2, -1, and 4. But my z coefficients will be replaced with that -2, -1, and 4. So there's my d sub z determinant. Again, I'm going to work with the second row because I have all 1 coefficients. So, alright, so the first entry of the second row is a positive 1. According to my coefficient matrix, I need to negate that. So minus the resulting determinant of whatever I should get here. So strike out the first column in the second row. That's going to give you a resulting determinant of 2, negative 2, 4, 4. Alright, so there's the first determinant. Let's rebuild this again here. So let's see, 1, 1, 3, 2, negative 1, negative 1. Okay. Now the second entry of the second row is a negative 1. According to my coefficient matrix, I need to take positive of that negative 1, so that'd be minus another determinant. That results from this time when I strike out the second column in the second row. So my resulting determinant is going to be 1, negative 2, 3, and 4. And then I got one more determinant to figure out. Alright, so let's see. 1, 1, 3. Let's see. 2, negative 1, 4. Negative 2, negative 1, 4. Alright. Then the final entry in my second row is a negative 1. According to my coefficient matrix, I need to negate that negative 1. So this time it'll be plus the resulting determinant of when I strike out the third column in the second row, which will end up giving me a determinant of 1, 2, 3, and 4. So now I have all my 2 by 2 determinants set up. Let's evaluate them. So negative of your first determinant, 2 times 4 is 8. Minus negative 2 turns into plus 2 times 4. That'd also be plus 8. Minus your second determinant, 1 times 4 is 4. Minus negative 2 turns into plus 2 times 3. That'd be plus 6. Then plus the third determinant, 1 times 4 is 4. Minus 2 times 3, that'd be minus 6. Let's simplify this. Negative of your first parentheses, 8 plus 8 is 16. Minus your second set of parentheses, 4 plus 6 is 10. Plus your final parentheses, 4 minus 6 is negative 2. So this will turn into negative 16 minus 10 minus 2. So this would end up becoming negative 28. So d sub z is equal to negative 28. So that means z is equal to d sub z over d. D sub z was negative 28, and then d was negative 7, giving us negative 28 divided by negative 7 would give us positive 4. So z had a value of 4. Therefore, the ordered triple then, now that we know all these, the ordered triple that's the solution to the system is going to be 0, 5, 4. So the ordered triple that's the solution to this system is 0, 5, 4. Let me get another black marker, because this one's about shot. So there's your solution. Let's go ahead and set up the next system. I'll leave the coefficient matrix thing up though, because that's going to come in handy for the next two that we do. Alright, what is the next system I want to solve? Here we go. Let's see. So we have 4x plus y plus 6z is going to be equal to 7. Then we have 3x plus 3y plus 2z is equal to 17. Then we have negative x minus y plus z is going to be equal to negative 9. Alright, so we have our very next system here. We have 4x plus y plus 6z equals 7, 3x plus 3y plus 2z equals 17, negative x minus y plus z equals negative 9. So first thing we got to do, find our d, which is just the coefficient determinant. So you're going to leave all your coefficients alone. So take your x coefficients, your 4, your 3, your negative 1. Then take your y coefficients, the 1, the 3, the negative 1. And then your z coefficients, the 6, the 2, and the 1. And then you'll find the determinant of that to find your d. Well, I think in this case we're going to work with the third row since all the entries are 1. So according to my, let's see, the first entry of the third row is negative 1. According to my coefficient matrix, I need to take positive of negative 1, so that would just be negative of whatever the resulting determinant is. The resulting determinant is when I strike out the first column in the third row. So now my resulting determinant is going to be 1, 6, 3, 2. Alright, so there's my first determinant. Let's just rebuild this real quick. So 4, 3, negative 1, 1, 3, negative 1, 6, 2, 1. Alright. The second entry of the third row is also negative 1, but according to my coefficient matrix, I need to negate that negative 1, so this would turn into plus the resulting determinant of when I strike out the second column in the third row. So that resulting determinant is going to be 4, 6, 3, and 2. And then I'm going to have one final determinant I need to figure out. Let's see, negative 1, 1, 3, negative 1, 6, 2, 1. Alright. So then the third entry of the third row is positive 1. According to my coefficient matrix, I need to take positive of positive 1. So that would be plus whatever determinant that's going to yield when I strike out the third column in the third row. The resulting determinant ends up being 4, 1, 3, and 3. So there's my three determinants. Now let's go ahead and evaluate them. Negative of the first determinant, 1 times 2 is going to be 2. Minus 6 times 3, that'd be minus 18. Then you have plus your second determinant. 4 times 2 is 8. Minus 6 times 3, that'd be minus 18. Plus your third determinant, 4 times 3 is 12. Minus 1 times 3, that'd be minus 3. Let's simplify the parentheses. Negative of your first parentheses, 2 minus 18 is negative 16. Plus your second parentheses, 8 minus 18 is negative 10. Plus your third parentheses, 12 minus 3 is 9. This turns into 16 minus 10 plus 9. Which, see, that'd be 6 plus 9, that'd be 15. So you end up getting your D determinant to be 15 for your coefficient determinant. So D is equal to 15. Now from there, we can go ahead and solve D sub x, D sub y, and D sub z. And then get our values for x, y, and z. So let's go for D sub x first. D sub x, to find that then, since you're going for x, you're going to take all your x coefficients, replace them with a 7, 17, and negative 9, but leave your y and z coefficients alone. So 1, 3, negative 1, 6, 2, and 1. Well, I'm looking at this here, and with the smallest numbers, I'm going to say we should work with the second column. Let's go down the second column this time. That has the smallest numerical value. So the first entry in the second column is a 1, but according to my coefficient matrix, I need to negate that 1, so it'll be minus the resulting determinant. Now I have to strike out column 2 and row 1, giving me the resulting determinant of 17, 2, -9, and 1. And let's go ahead and rebuild this a little bit here so I can do the next determinant. Let's see, that was 7. All right. 1, 3, -1, and then 6. All right, my second entry in the second column was a positive 3, and according to my coefficient matrix, I need to keep that positive 3 positive. So this will be plus 3 times the resulting determinant of when I strike out the second column and the second row. So my resulting determinant would be 7, 6, -9, and 1. Okay, let's rebuild this one more time. Alright, so now I'm going to work with the third entry of the second column, which is -1. But according to my coefficient matrix, I need to negate that -1. So I'm just going to turn into positive. It'll be plus the resulting determinant of whatever's left when I strike out the second column in the third row. So the resulting determinant would be 7, 6, 17, and 2. Alright, so now I have my 3 2x2 determinants, so let's evaluate them. Negative of your first determinant, 17 times 1 is 17, minus 2 times -9, it actually turns into plus 18. Then you have plus 3 times the next determinant. 7 times 1 is going to be 7, minus 6 times -9, that's actually plus 54. And then you have plus the final determinant, which you have 7 times 2 is 14, minus 6 times 17. Let's figure out what that is. I don't know offhand. I think it's 102, but let me be sure. It is, so it'll be minus 102. Alright, so let's work inside these parentheses. Negative of your first one, 17 plus 18 is 35. Plus 3 times what's inside your first parenthesis, 7 plus 54 is 61. Plus what's in the third parenthesis, so 14 minus 102, I believe, is -88. But let me just double check my work there. Alright, come on. Yes, minus 88, yep. Alright, then we have, so let's simplify this, you'll have negative 35 plus 183 minus 88. Which, let's simplify this a little bit here. Yep, that's going to be positive 60. So d sub x is positive 60. So now we can solve for x since we know d sub x. So x is equal to d sub x over d. Well, d sub x was 60. divided by your d, which is 15, which is going to give you an x value of 4. So x is equal to 4. Found x, let's find d sub y and then y. Alright, so d sub y, this time we're going to leave our x coefficients alone, so that's going to, x would still stay 4, 3, -1, but all your y coefficients you'll replace with the 7, 17, and -9. Then you leave your z coefficients alone, the 6, the 2, and the 1. So I'm thinking we work with the third row again. That's probably the best one to work with. So your first coefficient in the third row is a -1, but according to our coefficient matrix, we need to take positive of -1, so that's going to be minus the resulting determinant of when we strike out the first column in the third row. Alright, so we have 7, 6, 17, and 2 for the first determinant. Now let's figure out the second one. Let's see, 4, 3, -1, and this would turn into -9, 6, 2, and 1. Alright, second entry of the third row is -9, but according to my coefficient matrix, I need to negate that -9. So this will be +9 times the resulting determinant of when I strike out the second column in the third row. So my resulting determinant is going to be 4, 6, 3, and 2. Then I should end up having one more determinant. Alright, so 7, 17, -9, 6, 2, 1. Alright, final entry of the third row is a +1. According to my coefficient matrix, I take positive of +1, so that'd be plus the resulting determinant of whatever's left over when I strike out the third column in the third row. So the resulting determinant is going to end up being 4, 7, 3, and 17. So there's my determinants. Now let's evaluate them. So negative of the first one, 7 times 2 is 14. This will be minus 6 times 17. Be minus 102. Plus 9 times your second determinant, which, let's see, 4 times 2 is 8. Minus 6 times 3, that'd be minus 18. Plus your final determinant, 4 times 17 is going to be 68. Minus 7 times 3, that'd be minus 21. So let's see, work inside the parentheses, negative of 14 minus 102, that'd be negative 88. Plus 9 times your second parentheses, 8 minus 18 is negative 10. Plus your final parentheses, 68 minus 21 is going to be 47. So what you get is 88 minus 90 plus 47, which would turn into 45. So d sub y is 45. So that means now y is equal to d sub y divided by d. D sub y is 45. D itself is 15. So 45 divided by 15 is 3. So y is equal to 3. Alright, so we know x and y. Now let's solve for d sub z. Now to solve for d sub z, you leave your x and y coefficients alone. So your x coefficients were 4, 3, negative 1. Y is 1, 3, negative 1. But your z coefficients are going to be replaced by the 7, 17, and negative 9. So there's your d sub z determinant. I think I like the second column with the smallest numbers. So let's work with the second column. First entry of the second column is a positive 1, but according to my coefficient matrix, I need to negate that positive 1. So it'll be negative of the determinant that results for when I strike out the second column in the first row. So that determinant that results would be 3, 17, negative 1, and negative 9. All right, let's rebuild this a little bit here. So let's see, so your y's are 1, 3, and negative 1. Let's see, this is actually 7. Okay. Second entry of the second column is a positive 3. Well, according to my coefficient matrix, I need to take positive of that positive 3. So it'll be plus 3 times the resulting determinant of whatever's left when I strike out that second column in the second row this time. So my determinant is going to be 4, 7, negative 1, and negative 9. So there is my second determinant. Now let's build another determinant. Alright, so 4, 3, alright, see, we got a 1, a 3, and a negative 1, 17. Okay. Now the final entry of the second column is a negative 1, but according to my coefficient matrix, I need to take negative of that negative 1, so that would be plus the resulting determinant of when I strike out that second column, and this time the third row. So my resulting determinant would be 4, 7, 3, and 17. Alright, so now we have all the determinants there. Let's evaluate them. So take negative of the first one. 3 times negative 9 is actually negative 27. Minus 17 times negative 1, that'd be plus 17. Now plus 3 times your second determinant. 4 times negative 9 is negative 36. Minus 7 times negative 1, that'd be plus 7. Alright, and then you have plus your final determinant. 4 times 17 is going to be 68. Minus 7 times 3, so that'd be minus 21. So there's your determinants. Now let's work inside the parentheses. Negative of your first one, so that's negative 27 plus 17. That would be negative 10. Plus 3 times your second set of parentheses. Negative 37 plus 6 is going, negative 36 plus 7 is going to be negative 29. Plus your final parentheses, 68 minus 21 is 47. So negative 10 is positive 10. And 3 times negative 29, I think that's negative 87, but let's double check. Yep, that's minus 87. Then you have plus 47. So 10 minus 87 plus 47, so let's see, negative 77 plus 47 is going to be negative 30. So d sub z comes to negative 30. Now to find z, you're just going to take that d sub z and divide it by d. Well, d sub z is negative 30 divided by d, which is 15. Negative 30 divided by 15 is negative 2. So z has a value of negative 2. Now that we know all three values, the ordered triple that's going to be the solution is going to be 4, 3, and negative 2. So here's the order triple, 4, 3, -2, which is the solution to this system of equations. I got just one more, then we're done with this lesson. All right, what is this last one here? Last one. So we have -3x plus y plus 2z is going to be equal to -14. We have 9x minus y plus 2z is going to be equal to -8. And then 8x plus 5y minus 4z is equal to 6. All right. So there is the final system that we're doing today. We have -3x plus y plus 2z equals -14. 9x minus y plus 2z equals -8. 8x plus 5y minus 4z equals 6. First, let's set up our coefficient determinant of d. Just find d. So just take all your coefficients for the variables. So for your x's, you have the -3, the 9, and the 8. For the y's, you have 1, -1, and 5. For the z's, you have 2, 2, and -4. So there's your d determinant for your coefficients. Now let's go ahead and do this. I like the looks of the second column again since you have 2 1s. So let's deal with the second column. So the first coefficient in the second column is a 1, a positive 1, but according to my coefficient matrix, I need to negate that positive 1. So it's going to be minus the resulting determinant of whatever's left then when I strike out the second column in the first row, which will give me a determinant of 9, 2, 8, and -4. Now let's deal with the next determinant in this. So I'll have to rebuild this again here. Wait, why did I scratch that one? I can rebuild that, no problem. -3, 1, -1, 5, 2, 2. Okay, there we go. The second entry of the second column is a -1, and according to my coefficient matrix, I need to take positive of -1, so that's going to be yet minus another resulting determinant of when I strike out still the second column, but this time the second row. That'll give me a determinant of -3, 2, 8, and -4. And then I still have one more determinant to figure out for this. So -3, that's a 9. All right, 1, -1, 5, 2, 2. Okay, there we go. Now the third entry of the second column is a positive 5, but according to my coefficient matrix, I need to negate that positive 5. So it's going to be -5 times the resulting determinant of whatever's left over when I strike out that second column, but this time the third row. The resulting determinant is going to be -3, 2, 9, and 2. All right, so now we have all of our determinants. Let's evaluate them. So negative of your first determinant, 9 times -4 is -36, minus 2 times 8, that's -16, minus your next determinant, -3 times -4 is +12, minus 2 times 8, that'd be -16. And then you're going to have -5 times the final determinant of -3 times 2 would be -6, minus 2 times 9, that'd be minus 18. Let's see, work inside the parentheses, so negative, let's see. So you have negative 36 minus 16 is going to be negative 52, minus your second set of parentheses, 12 minus 16 is negative 4. Let's see, minus 5 times your third set of parentheses, negative 6 minus 18 is negative 24. Let's simplify this then. Negative 52, so that's positive 52, minus 4, so that's plus 4. Then minus 5 times negative 24, that would be plus 120. So that would end up giving you 176. So D has a value of 176. That's kind of a large one. So D equals 176. Now that we know D, we can solve for D sub x, and then eventually for x. Alright, so let's do the D sub x. Now to find D sub x, you're going to take all your x coefficients, replace them with the negative 14, the negative 8, the 6, and then keep your y and z coefficients the same. The 1, the negative 1, and the 5. Then your 2, 2, and negative 4. Alright, again, I like the looks of the second column a lot because we have 1. So let's work with the second column. My first entry in the second column is a positive 1. So according to my coefficient matrix, I need to negate that positive 1. So it'll be minus the resulting determinant of when I strike out that second column in the first row. My resulting determinant is going to be negative 8, 2, 6, negative 4. Now I still have 2 more determinants to figure out. Alright, let's rebuild this. So that's a negative 14. Then your y's were 1, negative 1, 5. There's a 2. Alright. Second entry of the second column is a negative 1, and according to my coefficient matrix, I need to take positive of that negative 1, so it's going to be minus another determinant that results from still striking out the second column, but this time the second row. So that's going to end up giving me, of course, the determinant of negative 14, 2, 6, negative 4. And then we still have one final determinant to figure out. So negative 8, let's see, 1, negative 1, 5, 2, 2. All right. Now we got to, let's see, we have the third entry of the second column, which is a 5, and according to my coefficient matrix, I need to negate that. So it's going to be minus 5 times the resulting determinant of whatever's left when I still, strike out the second column, but this time the third row. So the resulting determinant is negative 14, 2, negative 8, and 2. Alright, so now I have my 3 2x2 determinants. Let's go ahead and solve this. So negative of the first one, negative 8 times negative 4 is positive 32, minus 2 times 6, so that'd be minus 12, minus your second determinant, negative 14 times negative 4, that's going to turn into positive 56, minus 2 times 6, that'd be minus 12, minus 5 times the third determinant, negative 14 times 2 is going to be negative 28, minus 2 times negative 8, that'd actually be plus 16. So let's see, minus your first set of parentheses, 32 minus 12 is 20. Minus your second set, 56 minus 12 is going to be 44. minus 5 times your third set of parentheses, negative 28 plus 16 is actually negative 12. So this will simplify into negative 20 minus 44 plus 60. So let's see, this will be negative 64 plus 60, you end up getting negative 4. Alright, so d sub x is equal to negative 4. So to solve for x, you'll take your d sub x of negative 4 over, well, let me write out the steps first. Take your d sub x over your d, which gives you negative 4 over 176. Let's figure out what that is. I know it's going to be a fraction, but what is it exactly when it's reduced? 44. Okay, so x would end up being equal to negative 1/44. So x has a value of negative 1/44. Alright, so now we know x. Let's find d sub y and solve for y this time. D sub y is equal to, let's see, this time since we're doing d sub y, leave your x coefficients alone. So you'll have negative 3, 9, and 8 for your x's, but your y coefficients replace with negative 14, negative 8, and 6, and then leave your z coefficients alone, the 2, and the negative 4. Alright, so there's your resulting determinant for d sub y. I like the look of the third column the best because it has the smallest number. So let's work with the third column this time. First entry of the third column is a positive 2, and according to my coefficient matrix, I need to do positive 2, so that'll be 2 times the resulting determinant of whatever's left over when I strike out the third column in the first row. So my resulting determinant is going to be 9, negative 8, 8, and 6. Let's rebuild this determinant again. Negative 3, let's see, so this time, let's see, negative 14 for this, then z was 2, 2, negative 4. Alright. Second entry of the third column is also a positive 2, but this time, according to my coefficient matrix, I need to negate that 2. So it'll be minus 2 times the resulting determinant of when I strike out that third column and second row. So the resulting determinant is going to be negative 3, negative 14, 8, and 6. And I will rebuild this one more time. Let's see, this will be 9, let's see, 14, negative 8, and you have 2, 2, and negative 4. All right. Final entry of the third column is a negative 4. According to my coefficient matrix, I need to keep that a positive negative 4, so that'll be minus 4 times the resulting determinant of when I strike out the third column in the third row. So that's going to end up being the determinant of negative 3, negative 14, and then 9 and negative 8. Alright, so there's my three determinants. Let's solve for them. So 2 times my first determinant, 9 times 6 is 54, minus 8 is plus 8 times 8, that'd be plus 64. Then minus 2 times the resulting determinant of this one, negative 3 times 6 is negative 18. minus 14, that'd be plus 14 times 8. Let me figure out what 14 times 8 is. That'd be 112. So plus 112, then minus 4 times the resulting third determinant. Negative 3 times negative 8 is positive 24. Minus negative 14 turns into 14 times 9. Should be 126, but yes, that's going to be plus 126. We're going to have some big numbers here. All right. Let's see. Work in the parentheses. 2 times, let's see. Should be 118, but let me just double check that here. Yep, so we'll have 2 times 118 minus 2 times, so this should be 94, negative 18 plus 112. Yep, 94. Then you have minus 4 times 24 plus 126, that's going to be 150. Alright, so 2 times 118 is 236. Minus that 2 times 94, that would be 188. Minus 4 times 150, that's minus 600. So we're going to have a large negative number here. That gives you negative 552. So d sub y is negative 552. Now to find y, you'll just take your d sub y, divide that by d, which is negative 552 over 176. Let's figure out what that is in reduced form. It's not going to be a pretty number, I can tell you that. Alright, I know it reduces to negative 138 over 44, which means it's at least going to reduce by another 2. Nope. This will end up being negative 69 over 22. So y has a value of negative 69 over 22. So now we are going to find d sub z and ultimately solve for z. Alright, so d sub z, to solve for that, leave your x and y coefficients alone. So your x's are negative 3, 9, and 8. Your y's will still be 1, negative 1, and 5. But all your z coefficients you're going to replace with that negative 14, negative 8, and 6. So there's your d sub z determinant. I think we'll work with the second column this time, since we have 2 1s in there. So my first entry in the second column is a positive 1, but according to my coefficient matrix, I need to negate that. So it'll be minus the resulting determinant of whatever is left over when I strike out that second column, and this time the first row. So the resulting determinant is going to be 9, negative 8, 8, and 6. Alright, now let's rebuild this determinant. negative 1, 5. All right, so the second entry in the second column is a negative 1. According to my coefficient matrix, I need to do positive negative 1, so that'll be minus the next determinant that's left. So still, strike out that second column, but this time the second row, which means the resulting determinant is going to be negative 3, negative 14, 8, and 6. And then we have one final 2 by 2 determinant we should end up obtaining. Negative 3 is positive 9 there. 1, negative 1, 5. Alright, negative 8 goes here. Alright. Then we have the final entry of the second column, which is a positive 5, but according to my coefficient matrix, I need to negate that. So that'll be minus 5 times the resulting determinant of when I strike out that second column in the third row. So my final determinant is going to be negative 3, negative 14, and then we'll have 9 and negative 8. All right, let's solve these determinants. So negative of your first determinant, 9 times 6 is 54, minus negative 8, that's plus 8 times 8, so that'll be plus 64, minus your second determinant, negative 3 times 6 is negative 18, minus negative 14, that's actually plus 14 times 8, which I believe is 112. Let's just be sure. Yep, so that's going to be plus 112. Alright, then you have minus 5 times the final determinant. Negative 3 times negative 8 is actually positive 24. Minus negative 14 turns into positive 14 times 9, which is plus 126. Alright, so let's see. Now let's work inside the parentheses. Negative of your first set, 54 plus 64 would be 118. Minus your second set of parentheses, negative 18 plus 12, that should be 94. Then you have minus 5 times your third set of parentheses, 24 plus 126 is 150. Alright, so this will turn into negative 118 minus 94 minus 750. What a large negative number we're about to have. Let's figure that out. Negative 118 minus 94 minus 750, that's negative 962. So d sub z is negative 962. Now we can find z by taking that d sub z and dividing it by z. Well, d sub z is negative 962 divided by your d of 176. Let's see what that is in reduced form. These are not pretty numbers to work with, but you will get answers like that sometimes. All right, 481. So let's see. So we start with negative 481 over 88. Can this factor any further? I sure hope so. Looks like we're stuck with z having a value of negative 481 over 88. So that's pretty hideous, but that's exactly what it is. So the ordered triple that's going to be your solution is going to be at negative 1/44, -69 22, 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 / 1 and negative 481/88. So yeah, that was pretty awful, but that's exactly what the solution is for this system. That's your order triple. So that's it for this lesson. Next lesson, we're going to start the final part of the matrices unit, which is working with inverse matrices. We'll get into what those are and how to form one, and then eventually how to use those to solve systems of equations. So I hope everyone has a great day. Take care.